Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
Hello everyone, welcome. Now we know all the basic elements and we know how they are connected, right? So now we are starting with Kirchhoff's law. Now before going to Kirchhoff's law, let us understand few basic terminologies. Now the first terminology is going to be active element. Now what do you mean by active element? It is the element which supplies energy to the circuit. Now which supplies the energy means any current source or voltage source will be known as active element. So in the circuit which is shown, V1 and V2 are the active elements. Okay, now let us come to passive elements. Now basically passive elements are the elements which receive the energy and then it converts it into heat, magnetic energy, or it stores that energy in the form of charges. Fine. So in this circuit, what are the passive elements? Passive elements are R1, R2 and R3. Well, in other circuits, in addition to resistors, we can have inductor also. Inductor converts electrical energy into magnetic energy, and we can have capacitor also, which converts electrical energy in the form of charges. Fine. And here resistor converts electrical energy into heat. So basically passive elements are going to be resistance, inductance and capacitance. Now there is a very important term called node. Now what do you mean by node? Now node is going to be any surface or any point where two or more circuit elements are joined. Now in this particular circuit, if you notice, at point P, V1 and R1 are joined. So node P, right? So point P is known as node. Similarly, if we talk about Q, R1, R2 and R3 are joined. So it is two or more, right? So even Q is a node. Now let us talk about R. Now again in R, R2 and V2 are joined. So R is again a node and S is not a node, right? Because only V2 is there. Now, but then if we talk about T, what is T? In T, R3, V1 and V2. These three are joined. Okay. So even T is a node. Fine. Next, we'll understand what is meant by a junction. Now node was where two or more circuit elements were joined, but a junction is where three or more circuit elements are joined. Now if you notice, PR are the nodes but they are not junctions. But if you notice Q, here R1, R2 and R3, three circuit elements are there. So Q is a junction. Similarly, T is a junction because in T, R3, V1 and V2, three circuit elements are joined. So Q and T are junction. Now let us understand what is meant by a branch. Now branch is basically any part of the network which is between two junctions. So here branch is going to be QT, right? So branch for me will be QT. Okay, so this is called a branch, this part. Fine. Secondly, we come to loop. What do you mean by loop? Any closed circuit path is called a loop. Then what is mesh? Mesh is basic loop, that is elementary loop, which cannot be further divided. So it is the smallest entity and loop can be a bigger entity. Fine. Now if we talk about this circuit, there are two loops, P, Q, T, U, that is this is a loop. Another loop is RQTS, which is this, right? So here we have two loops. I hope you understood this. Now let us come to Kirchhoff's current law. Now the first law is known as Kirchhoff's current law, which was given by Kirchhoff. Now basically it deals with node. Okay, so node is where two or more circuit elements are joined together. So if you notice here, this point is a node, right? And many currents are coming and going, right? So basically KCL states that the algebraic sum of the currents at the junction or a node in any electrical circuit is 0. Fine. Now how do we represent it? For that we need to take the direction into account. Okay, so for taking the direction, the entering current is what? If this is a node or a junction, if a current is coming towards it, then it is known as entering current. Now entering current is always taken as positive and leaving current is taken as negative. Now what do you mean by leaving current? Now suppose this is a node or a junction and a current is going away from it, then it is leaving current. So entering current is the incoming current and leaving current is an outgoing current. Fine. So let us understand what all are the incoming currents in this. I5 is an incoming current, right? I3 is an incoming current and I2 is again an incoming current. So we have to take these currents as positive. Now what is I1? I1 is a leaving current. What is I4? I4 is again leaving current. So leaving currents are taken as negative. So let us start writing. Now algebraic sum is the direction has to be considered. So for I1 we have to write minus I1. Fine. Then comes I2. So I2 is entering current, right? So it is plus I2. Now what about I3? Again entering, so it has to be plus. So it is plus I3. Now I4 is a leaving current, so it has to be minus I4, right? Similarly I5 again is an entering current, so here we will write plus I5. Now this algebraic sum is always 0. Now if you take these two negative terms to the right hand side, your circuit current equation becomes I2 plus I3 plus I5 equal to I1 plus I4. So this is it. So this is how we apply Kirchhoff's current law. Now there is another way of stating this law is algebraic sum of the leaving currents is equal to the algebraic sum of the entering current. Okay, even we can define the law like this also. Now I hope this is okay for you. Now let us understand what is another law. And the second law which was given by Kirchhoff is Kirchhoff's voltage law. Now Kirchhoff's current law basically dealt with current, and Kirchhoff's voltage law, which is shortly known as KVL, is dealing with voltages. So suppose you have a circuit wherein you have many circuit elements. So obviously we know that all the circuit elements consume some voltage. So there is always a voltage drop across all circuit elements. Now the voltage which is developed across any circuit element is known as voltage drop. And the voltage which is supplied by the active element is known as EMF. Okay, so E1 and E2, like V1 and V2, are known as EMFs. But suppose there is a resistor connected in the circuit and there is a current flowing through it. So voltage will be developed, which is given by Ohm's law, which is I into R. So that is called a voltage drop. So Kirchhoff's voltage law says that the algebraic sum of EMFs and voltage drops in a closed circuit is 0. Now how to write the KVL equation, we will understand it once we start solving the numerical. But before that, again, as we did how to find out the direction, because here the direction is very important. In current we understood how to take the direction of current. Here we need to understand how to take the direction of the EMF. Now here you can see that this is a positive terminal and this is the negative terminal. So when we are moving from positive to negative, we take it as minus. Please remember this very carefully. This is very important. And now when this is negative and this is positive, so when we are moving from negative to positive, we take it as positive. Negative to positive, we take it as positive. Positive to negative, we take it as negative. This is EMF. Fine. Another point is when we are going through a resistor. Okay, so always we need to assume the direction of the current. Okay, so we can assume it in any direction. Now here you can see that through R1 I have assumed the direction of current from left to right. Correct? So in this direction from left to right the current is flowing. Now if we are moving in the direction of the current, then we take it to be negative. If we are also moving in the same direction, then we take it to be negative. And if the current is, see here the current is flowing from right to left, but we are moving from left to right, it means we are moving in the opposite direction. So we take it to be positive. So if we are also moving in the same direction to that of the current, we take the voltage drop to be negative. If we are moving in the opposite direction to that of the current, we take it to be, yes, positive. Fine. Now let us understand how to apply these laws. Okay, so this will be more clear when we solve this numerical. So numerical says determine the branch current by using Kirchhoff's law. Now branch current means, branch is what? Yes, exactly. Branch is where three or more branch is the circuit element between two nodes or junctions. So here 3 ohms, 2 ohms and 4 ohms resistors are branches. So basically he wants to say that we need to find all currents which are there in the circuit. Okay, so the very first thing to solve these kinds of circuit is to assume the direction of the current. Now how to assume the direction of the current? For that we need to consider the supply, how the supplies are connected. And we know that a current flows from positive terminal of the battery and comes back to the negative terminal of the battery, right? So here what I am going to do is, since this is a positive terminal, here I will assume that the current flows in this direction. It goes to this, again it comes here, right? Similarly, this is I1, okay? This is I1. Now similarly you have one more current which flows because of 40 volts supply. So this is positive terminal. So here the current flows in this direction. So this is I2. Fine. So this flows in this way. Finally it comes to this point and this is my junction or node. So here I1 and I2 add up. So basically through 2 ohms I1 plus I2 flows. So addition of I1 and I2 is flowing through 2 ohms resistor. Fine. So here we will be moving in this direction, in the clockwise direction. Fine. So let us start applying KVL. So for KVL, what is the first resistor? 3 ohms. And we are also moving in the clockwise direction, means left to right, and the current is also flowing from left to right, so we have to take it to be negative. And voltage drop is I into R, right? So I into R means 3 I1. Got it? Now we are coming in the downward direction, that is through 2 ohms. Okay, so we will write, now see, we are also moving in the downward direction and the current is also flowing in the downward direction, so we have to take minus. Now what is the voltage drop across 2 ohm resistor? It is 2 into the current. Now what current flows through 2 ohm resistor? That is I1 plus I2. So here we will write I1 plus I2. Fine. Now we go from this to this. So now we are going from minus to plus. So when we go from minus to plus, we take the the voltage to be positive. So here we will write plus 35, and it says that this addition is equal to 0. And then we will solve it. So it is minus 3 I1 minus 2 I1 minus 2 I2 plus 35 equal to 0, right? So we take the negative terms to the right hand side and we will finally write the equation. So my final equation becomes 5 I1 plus 2 I2 is equal to 35. Fine. So this becomes equation number 1. Okay. So my first loop is over. So what I'll do is I'll erase this part because that is of no use for me now. Okay. So now we will talk about this loop, and this we will consider to be in anti-clockwise direction. So we are moving from right to left. Okay. So now see, we are moving from right to left, and the current which is flowing through 4 ohm is also moving from right to left. So we have to take it to be minus because we are moving in the same direction. So the current equation becomes minus 4 I2. Okay, minus 4 I2 because I2 is flowing through 4 ohms and we are moving in the same direction, so it has to be negative. Now we are coming to this part, right? So we are moving in the downward direction. The current is also moving in the downward direction. So we have to again take it to be negative. So minus 2 I1 plus I2. Now we come to this. So nothing is there. Now we go here. So we are going from again minus to positive. So we have to take it positive plus 40, which becomes equal to 0. So now we will open the bracket and we will solve this equation. So it is minus 2 I2 minus 2 I1 minus 2 I2 plus 40 is equal to 0. Okay. Now again we will solve this and we will take the negative terms to the other side. Okay, so we will have 2 I1 plus 4 and 2 6 I2 is equal to 40. Okay, so this is equation number 2. So basically here we have two simultaneous equations and we need to solve these simultaneous equations. Okay, so how to solve these simultaneous equation? We have already studied this, right? So if you notice that here no common term is there. So to solve it for I1, you can multiply equation 1 by 2, multiply equation 1 by 2 and multiply equation 2 by 5. Fine. So I1 terms will get cancelled, correct, and you will get I2 terms. Fine. So please pause the video and solve it. Okay, so what did you get? What is the value of I2 now? What is the value of I2? I2 comes to be 5 amperes, right? So here we get I2 to be 5 amperes. Now we will put the value of I2 in the equation. Okay. And we will calculate what is the value of I1. Okay. Now I1 would be 35 minus 2I2 whole upon 5. So please tell me what is the value of I1 from this equation. Very good. Even the I1 value comes out to be 5 amperes. Okay. So what did we get? We got that this current, which is I1, this current, which is I2, both are same to be 5 amperes. Correct? And thirdly, from 2 ohm resistor, I1 plus I2 flows. So I1 plus I2 flows through 2 ohms resistor, and that current becomes 10 amperes. Fine. Now let us understand the direction. Now I1 flows in this direction, I2 flows in this direction, and I1 plus I2 flows in the downward direction. Now how did we conclude this? Now suppose we have assumed a direction of the current and the calculated current is positive. It means whatever was the assumed direction, it was correct. Now we assumed a direction and the calculated current comes out to be negative. It implies that the direction of the current is opposite. Fine? Okay? Now let us go to the second numerical and we will understand how to solve it. So this is going to be a step ahead. So this is how the circuit looks like. Okay. Now here you need to determine the potential at point P and Q. Okay. Where are potential P and Q? Fine. So the points P and Q are specified. So again we need to find out the direction. So first we will assume the direction. So how are we going to assume the direction? Depending on the battery connection. So according to battery connection, my current flows in this direction. Fine? Yes. So it comes back. Fine. So this is the direction of I1. Secondly, let me see how I2 flows. So again, depending on the direction of 20 volts, I can conclude that I2 flows in this direction. Fine. So this is how I2 flows. Okay. Now I will start writing the equation. So for that, first let me name the points. So this is A, B, C, D, E, F, G, H. Fine. Okay. Yes. So we will move ahead now. Now we will apply KVL in this loop. Okay. And we are going through path C, B, A, D. So we have to name the loop according to the direction we are moving. Fine. So how to write this? Now CB. What is there in CB? What is there in CB? You have 30 volts power supply. Correct? So 30 volts power supply is, we are moving from C to B and the direction of the power supply is also negative to positive. So we have to take it to be positive. So plus 30. Then CBA. So we are moving from B to A. We are moving from B to A means right to left, and the current is also flowing in the same direction. So we have to take it to be negative. So the voltage drop is going to be minus 5I1. Next, AD. We are also moving in the same direction. So again it would be minus 10I1. Then D to C. Right? So again same direction. So it comes out to be minus 15 I1. This whole becomes 0. Okay, so plus 30 equal to 5 plus 10, 15, 15 plus 15, 30 I1. So what is the value of I1? The value of I1 comes out to be 1 ampere. I hope you understood. Correct? So now let us go to the second loop. Okay. Now first let us erase it. Now second loop was first loop was ABCD and the second loop was E, F, G, H. And here we are moving in clockwise direction. Let us understand the direction of the current. Yes, so this was the direction of the current. This is I2. So again, please start writing the equation with me. Now I will write loop E, F, G, H. Okay, so we are moving from E to F. The current is also going in the same direction. So I will write minus 4 I2. Again, F to G. Current is also flowing from F to G. So it would be minus 10 I2. Then G to H, minus to plus, so plus 20. Then H to E, same direction, so minus 6 I2 is equal to 0. So it comes out to be minus 4 I2 minus 10 I2 minus 6 I2. So what is the total? The total is 4 plus 10, 14 plus 6, 20. Yes, so we get 20 I2 is equal to 20. So finally I2 comes out to be 1 ampere. So even I2 is 1 ampere, right? So even I1 was 1 ampere and we got I2 to be 1 ampere. Now there is a very important concept here. Now we have not written anything about this part. Now why? Because this is an open loop. It is not a closed path. So no current flows through open circuit, open path. Because there has to be some connection actually here. If we had this connection, then we would have said that it is a closed circuit path and some current will be flowing through it. But now since it is an open circuit path, no current flows through this. Fine. Okay, so now let us understand what is the next step. So here the direction is mentioned. So now we have to, actually we have found out the current, now we have to calculate the potential. Okay, so the path which we have taken for potential at point P and Q will be, we will be moving from Q to P. See, the arrows are shown. Okay, the arrows are shown. It is moving from Q to P. So we have to write the KVL equation for that. Okay, we are moving from, remember, Q to P. So what is going to be the potential equation? We are going from this direction, okay, but the current flows in this direction, so we are moving in the opposite direction, so we have to take it to be positive. So it comes out to be 4 and the current flows through it is I2. Then we come from this. Okay, so again we are moving in the opposite direction, so we will write plus 6 I2, right? And 4 ohms, so across 4 ohms no current flows, right? Now we are going through 5 volts and we are going from minus to positive, so it has to be plus 5. And the current I1 flows in this direction, we are moving in the opposite direction, so we have to take plus 15 I1. Okay, so we will place the value of I1 and I2 which are 1 ampere, so we get 4 plus 6 plus 0 plus 5 plus 15. So what is the total value? 4 plus 6, 10, 10 plus 5, 15, 15 plus 15, 30. So the potential difference across PQ is 30 volts. So this is how we calculate the voltage. Okay, we will solve few more numericals in the next lecture.